Good evening. How are you? I am Takiwa Smith, founder and executive director of Science, Engineering, Mathematics Link Incorporated, and I want to welcome you to tonight's Teen Science Cafe. The Teen Science Cafe is a program of our Math and Science Career Academy where we provide teens with the opportunity to learn about STEM careers by meeting and interacting with a STEM professional where they can learn about their career journey, learn about their current work, and get an example of what the STEM professional does every day. And so I'm going to turn it over to our program coordinator, Carlin Pounders, that is going to introduce our speaker for today's cafe.
Hi everyone, my name is Carlin Pounders. So our speaker today is Miss Jessica Harris. She is a physicist, an informal educator, science communicator, and diversity and inclusion change agent. She has a decade of progressive leadership experience in education and public outreach and equity, diversity, and inclusion. She is an enthusiastic and engaging public speaker with an affinity of explaining complex science topics to a variety of audiences, large and small. Ms. Harris really focuses on interactive presentations, so we are really in for a treat with what she has for us tonight. So without further ado, I will go ahead and pass it over to Ms. Harris.
Thank you guys so much for having me today. I really appreciate this opportunity. Talk about astronomy. So I'm going to go ahead and display my screen. Everything look good?
Looks good.
Okay. So today we're going to be talking about exploring the wonders of the universe. It's one of my favorite topics to talk about astronomy. And so specifically today we'll be talking about multi-wavelength astronomy and how that's really important, all these different wavelengths. So who I be? I am Miss Jessica Harris. I am, as you heard before, I'm a physicist, a science communicator, consultant, and the program director of the Clark Scholars Program here at the University of Virginia. I've given many talks over the years. What's not written here is also that I am a mother of two amazing kiddos. I call them my minions. They're in the bottom right image in infrared, one of my favorite topics. So that's a little bit of who I be currently, and I want to talk to you guys about my STEM journey. So when I was a little girl, this little girl right here, about 8 years old, if you asked me what did I want to do when I grew up, I would always tell you that I wanted to be a teacher. From elementary school, middle school, high school, even when I graduated from high school, I said that I wanted to be a teacher. Then I met this amazing man here. His name was Dr. Tang Zhu. He was a physics professor at Grambling State University. Go Grambling. Whoop, whoop. It's a HBCU in Louisiana. And I had him for a physics class for non-science majors. And I actually declared when I started my freshman year, I declared my major as secondary education with a concentration in math. Again, wanting to be a teacher, sought out going to Grambling because of their education program. And then I met Dr. Zhu. And Dr. Zhu was trying to convince me to switch over to physics. And he was really good. He knows that students need help with textbooks. And he was saying that if I came a part of his program that he was leading, the LSAT program, that he would help pay for my books. He was an amazing man. He got me my first internship at Duke University, and he passed away my sophomore year. It was really devastating. When I tell you he was an amazing mentor, he is what I base all my inspiration now about mentoring. And so I had to share this story about him. I always tell a story about him, that he was in the ICU in Ruston, Louisiana, which is about not too far from Grambling, literally in the ICU. And he was telling me what internships to go through for the next 2 years of my career. And I actually was so fortunate and so blessed to go to all of those internships. The last internship, so he was just an amazing man. If it wasn't for him, I wouldn't have started my journey in physics. And I'm grateful that I switched my major into physics into my sophomore year, and I've never turned back, and I'm so grateful for that journey. One of my last internships was at Vanderbilt University. It was an astronomy-based project, and I learned about the fifth Vanderbilt Master's and PhD program. By the time I graduated from Grambling, I wasn't 100% sure that I was ready, 100% sure that I was ready for a PhD program. And so I was grateful to learn about the Fifth Vanderbilt, but not even just grateful to learn about it, glad that they accepted me into their program. And I graduated from Fisk University in Nashville in 2010. That's me there on graduation day. So after that, I decided that I didn't want to continue on my PhD in astronomy, but I was really passionate about talking to the next generation about these science topics, really making it relatable to everyone else. And so in the bottom corner here, it's cut off a little bit, but I graduated in May and started in the summer in June at Space Telescope Science Institute in Baltimore, Maryland as an intern. I was 2 weeks from ending the program. We were giving our final presentations, and the head of the Education and Public Outreach Department, her and the team watched my presentation, and they decided they wanted to bring me back for a short contract period of time. That contract period of time actually led into a job being created for me at Space Telescope, and I was at Space Telescope for 7 years. And so I have here the James Webb Space Telescope. I love James Webb. I don't know if you can see right now, but I have a James Webb necklace. But James Webb Space Telescope is an amazing telescope that's going to launch. They just announced a few months ago, launch October of next year. And why James Webb was my favorite, because I've spent that 7-year part of my career literally talking about James Webb in getting the public interested and engaged about this amazing next generation space telescope. So it'll always have a special place in my heart, and it's where I started my career. And so I told you guys earlier, I came to Space Telescope as an intern, and 4 or 5 years later at Space Telescope, I was actually the director of their summer student program. And this was the first cohort of students that I led. And they made this amazing montage of themselves for me at the end of the program. And so it was a full circle moment. So I want to pause here to say that as part of my STEM journey, it was always fueled. You learned earlier that I was an informal educator. It was always fueled on wanting to give back, wanting to do outreach, but the core of it is teaching. And so I've been really grateful to have a full circle moment that I came to Space Telescope as an intern and left Space Telescope as the director of the program. And so I'm grateful that I got to do informal science there at Space Telescope. Learning a lot about the informal education space, but also being able to work with students, which is a great passion of mine. So after that 7 years, I accepted a job here in Charlottesville at the National Radio Astronomy Observatory, in NRAO for short. They lead and operate the Very Large Array and the Atacama Large Millimeter and Submillimeter Array. So the top left image is the VLA, 27 dishes, and the ALMA is 22 dishes in Chile. So this picture always freaks people out. I'm wearing an oxygen mask because we're really high up. We're about 17,000 meters above Earth's surface, and so it's just a little thin there. So it's oxygen mask, I was totally fine. And then the bottom image here is the Green Bank Observatory in West Virginia. And a fun little fact that people don't know is I'm actually really afraid of heights, and I'm sitting on top of Green Bank's telescope. That was a little scary. So I was pretty brave stepping out there. So I mentioned to you guys working with students at Space Telescope. I also worked with our NAC program, which is the National Astronomy Consortium at NRAO, leading the site here in Charlottesville. And this was our NAC meeting. I love this image because we were having so much fun, and someone just really captured this moment. But it's something that I really enjoy working with students. But I love this image. So I mentioned earlier, I am currently at the University of Virginia. I am leading the A. James Clark Scholars Program. It's a program specifically dedicated to students traditionally underrepresented within engineering. This is just a snapshot. You can't see their individual faces, but we just met. They started classes this week, and these are the amazing scholars that I get to work with on a day-to-day basis. So I say in summary of my STEM journey that it's okay to follow your passion and dreams, even if it means you have to be a trailblazer of a new path. People often ask me, how did I get into education and public outreach? How did I do all of these things? And it literally was from that little girl that I showed you guys earlier of wanting to be a teacher. And along the way, as I matriculated through my master's and my bachelor's program, there was a deeper desire to really dismantle and really address the inequities within our STEM field related to our undergraduate and just K through 12 students within our spaces. And so all of those passions continue to drive my work, continue to drive what I do. So follow your passions, follow your dreams. They won't lead you astray. So I have an introduction to our activity today about multi-wavelength astronomy that I was talking to you about earlier. Do we want to pause for a second? Are there any questions? Okay. Just want to make sure.
No questions yet.
No questions. Okay. I'll go back to playing. Okay, so multi-wavelength astronomy has to do with the electromagnetic spectrum. It's a really scary word, but I promise you that you are familiar with the electromagnetic spectrum, even though you may not know. So gamma ray and X-ray are very high energy wavelengths of light. X-ray, you know, like if you go, like I recently broke my toe a couple of months ago. You have to go get an X-ray to see what's going on with your bones. So you're familiar with that. UV, we need to wear sunscreen because of UV light. Visible is the only part of the spectrum that us humans can see. So visible light we're very familiar with. It's how you can see that I'm wearing white. I don't know what you're wearing, but whatever color you're wearing, if you're able to see that, then that's from visible light. Then infrared, I'll talk to you about a little bit later with the James Webb, but infrared is like heat. If I had an infrared camera here, you would see that I'm giving off heat. Microwave, like you're using a microwave to pop your popcorn, and radio, not necessarily the radio that you hear when you're getting in the car, but it's the longest wavelengths of light. And that's what I was telling you that the VLA and ALMA view in. So multi-wavelength astronomy is really important. If you think about it like a detective, we have all this amazing science that's out there, but we can't go travel to Jupiter. We can't go travel to a nebula or a galaxy, but we can study the wavelength to really understand what's going on. And so the image you have here, they're both from the Hubble Space Telescope that was launched in 1990. It's an amazing telescope. It's celebrating 30 years this year. This is Jupiter. So Hubble can see invisible, infrared, and UV. And so the image that I have, here is Jupiter invisible. And the very top that you're seeing there is aurora on the top of Jupiter, and that's in UV. And the image bottom here, the really colorful blue, green, pinks, is Jupiter with Hubble Space Telescope's NICMOS, which is the Near Infrared Camera Multi-Object Spectrograph. It's viewing that in infrared light. Then you have the Chandra X-ray Observatory, which sees an X-ray kind of in its title. And it's, again, Jupiter. But you're seeing the aurora, these really, really interesting things that are going on in your X-ray. Okay, then you have Spitzer, which sees specifically in infrared wavelengths of light. And this image right here on your right is one of my favorite images, one of my favorite objects, which is the Orion Nebula. A nebula is like a ball of gas and dust in space. And what's really amazing about Orion is that it's really close within our solar system. It's one of the well-studied nebulas that we have. In the winter months, you're able to view the Orion constellation, which Orion Nebula is located in. And this is also what I did my work on for my thesis. So always, again, James Webb and Orion are my favorite things to talk about. So the image you see here on your left is Orion Nebula in the visible. This is visible too in the middle here, and then Orion in the infrared with Spitzer. Then we have the Very Large Array that I was showing you guys earlier. It has 27 dishes. It's located in New Mexico, and it sees in those long wavelengths of light that you saw that got through Earth's atmosphere. And the array of the antennas operate like one big telescope. So with Hubble, you have one primary mirror. You have a primary mirror and a secondary mirror. That's 1.5 meters in diameter. But the the arrays and in Mexico with VLA act like one big primary mirror. So it's 27 dishes that can be moved. They actually don't stay in one configuration. They can be really tight to miles in diameter. And the image that's kind of going back and forth, the GIF that's there, is visible from Hubble and the giant red spot in the radio that you're seeing there. So this is the Crab Nebula. It's also maybe one of my top 2 favorite objects because it's so dynamic. So I told you a little bit earlier, just now, with Orion, it's a place I actually didn't mention. I'm sorry. Orion, in this place, is a place where stars were being born in Orion. But this Crab Nebula is actually an example of where a star exploded. Like it just like blew out its contents, and we've been studying it for a long time. Actually, when it exploded about thousands of years ago, it was so bright that you could see it in the daytime for about a month period of time. And so this is a great example of the multi-wavelength. So I showed you guys Hubble Space Telescope, Chandra, Spitzer, one of the radio-based telescopes, but we need each wavelength, as I was telling like the detective, we need each wavelength to tell us different information about what's happening. And so when astronomers assign these colors, like the radio is in red, most radio images actually are in red. It's defaulted that way, but we actually can't see it, but that's just the color we choose to represent radio. Your infrared, optical, ultraviolet, X-ray. X-ray also tends to be this purple when you're seeing the images. But as you can see, like you're seeing subtle differences in the radio, the infrared, the optical, the ultraviolet. And then this X-ray actually has this, we didn't even know until we saw this in X-ray, that there's actually a really amazing like something happening with the star where it's shooting out these jets that we never would have been able to see if we didn't have the X-ray wavelengths of light. So it's really dynamic. We need all the different wavelengths to tell us unique stories. And so now I will turn off my screen and I'll just pause for a second if there are any questions before we go into our activity.
There are none in the comments right now.
Okay, perfect. So I'm going to switch to my web browser. The link that I'm going to on the website is go.nrao.edu/color. So you may be wondering, okay, Jessica, we talked about these amazing images. Like, I want to go and create my own image. Perfect. I got the thing for you. So the National Radio Astronomy Observatory has the Cosmic Coloring app, where you're able to go in and create your own images. So of course, when you get on the landing page, not of course, but as you get onto the landing page, it's the Crab Nebula. This is exactly how it looks when you first get into the website. And all of the options are turned off. Of course, it's the National Radio Astronomy Observatory, so the radio is turned on. But I'm going to go ahead and turn on all of the wavelengths: infrared, visible, ultraviolet, and X-ray. And you kind of see the image that we created earlier in the image that I showed you about the Crab Nebula. You can change the brightness up and down. It may not be as obvious. I'm actually going to turn these off so you can kind of see me playing with the brightness. With the sheet on the X-ray. So you can turn up and down the brightness to your liking. Kind of like this here. And then when you're done playing around, you've gotten it as you want to. You can change colors. They're defaulted to certain colors, but you can go in and change them. You can make ultraviolet orange if you want to, or red, purple, blue, whatever you like. And then if you're happy and satisfied, you click generate. It takes a little while for it to generate. I'm using Chrome. It also works. I'm on a Mac. I'm using Chrome, but you can also use it in Safari. So you have amazing image, then you can right click and save this as your desktop. If you're following along with me now or later, definitely show us what you did. I love to see the different images that you created. So again, it defaults on the Crab Nebula, but there are about a half a dozen other images there, like the Whirlpool Galaxy. Let's click on, let's click on the Milky Way, the Galactic Center. So whatever image that you want to select, you select it here, then you select image, and then it will load the image in. Sorry, well, that was a good one too. Let me go back to the Milky Way. So the Milky Way Center. And then you can play around with what you're seeing. And again, do the generate to create a new image you can save for your desktop. There. Okay. While I'm here, before I go back to my slides, I told you guys I love James Webb. I've been talking about James Webb for a very long time. I want to show you guys the deployment sequence. So this is a short video. James Webb is going to launch in French Guiana. Cross our fingers, October of 2021. And this is the sequence. I'm going to go ahead and press play. So it's going to launch in an Ariane 5 rocket. And it's going to take about a month to travel to its destination at L2, but we'll get there. And so this is just the sequence you're seeing is the slow deployment of James Webb. So it's launched in its Ariane 5. It's folded up really, really tight. And then it's going to do this beautiful deployment sequence as we go through. And so you have the solar panels that first get launched. You'll see coming up quickly, of course, the antenna. So this is going to be speaking back to us in Earth. Mission control will actually be at Space Telescope Science Institute. It's really exciting. So you see we're about 18 hours in. Really exciting stuff. So when you are thinking about this in October, you'll hopefully be thinking about the sequence of things happening. So that's the antenna deployment there. Allows us to communicate with James Webb. And you'll see within 2 days, James Webb has already reached a little bit past the moon. I'm just so amazed. So as it's doing the sequence, what I want to say, what's so exciting about James Webb that's adding a new dimension, I'll go back to my reference of, this is the pallets, the sun shields, which helps protect James Webb to keep it really cold and keep it really hot. But what's really exciting about James Webb, I mentioned to you guys earlier about the Orion Nebula. It's a place where stars are being born. Also within Orion are called protoplanetary disks. It's a really long word, but it's actually where solar systems are forming. Planets are forming around the stars that are being birthed in Orion, and James Webb will be able to really study. So right now, we're able to observe with not much detail about what is that planet made of, what's going on, and James Webb will give us deeper understanding of that. So it's one of its mission goals. So these, this is about the size of a football field. It's really big. It's small in here, but it's actually really, really big. And so it's going to take a few days for the sun shields to unravel. It's really complicated, as you can see. Part of the delay for James Webb launching is just testing, because we cannot, like Hubble. I don't know, for those who may be a little bit older, when Hubble was first launched, there was a flaw in its primary mirror. But fortunate that we still had the ability to send up astronauts to go and fix and service Hubble. That was the initial intent when we launched Hubble, when Hubble was launched. But with James Webb, it's launched, and we can't fly to James Webb and service it. So we want to test, and make sure that everything is perfect with James Webb. So it has 5-layered sun shields. I love that like movement that it does as it kind of etches up and then expands. So I mentioned to you earlier that Hubble has one primary mirror. James Webb is very different, that it has 18 segmented gold mirrors. A fun fact about the gold mirrors, you think, oh, it's gold, it's really expensive. It's actually only a wedding ring worth of gold. on James Webb, but it's 18 segment mirrors acting like one primary mirror, a similar but different concept than the radio that I was telling you guys about earlier. And then its secondary mirror will come down. And so in astronomy and the astronomy that we're talking about here, you have to have a primary mirror and a secondary mirror. So the light will come in and hit the mirrors, the 18 segments. It'll bounce to hit the secondary mirror. And then in this black center here is the tertiary mirror, where all the instruments, all the amazing science is going to come out of James Webb is in the back here on the instruments. So the wings have deployed. We're 14 days in. It's amazing. And then it zooms. I want to catch it before it gets to L2. So we're 29 days. I told you it's about a month that it takes to get to its final destination. So it's going to begin this halo orbit around L2. I always try to catch it right before it does this spin. There we go. So James Webb will launch. It's going to take about a month to get to its final destination, and then it's going to orbit within this L2 orbit there. So that's really exciting about James Webb. So look out for that in October 21. I know you're like, it's too long, but it's really exciting and discoveries that we're gonna find with James Webb. So I wanted to have this up here, as I mentioned earlier, with the colorizing app. Please share with us your images. I'd love to see them. Please @ me. So on Twitter, Simlink, Tokia's Twitter, my Twitter is astromime, and then on Instagram it's astro_mime. And then I'll open it up for any questions. And I wanted to just show, sorry, real quickly. This is actually the James Webb Space Telescope at Northrop in California. This is the real deal telescope there. Stunning. I'll take any questions.
So you talked about the impact of having a mentor in your life. For the teens that are listening, what are some tips that you can give them as far as identifying a good mentor and building that relationship?
That's a really good question about identifying a mentor. One of the things that Dr. Z used to always tell me is that when the student is ready, the mentor will come. I was very fortunate to have him in my life. I wasn't seeking a mentor. I didn't know that I needed a mentor. I was very grateful that our paths crossed and he was invested in me. I tell this story, I wrote about it in my blog. I tell this story about once, like, I wasn't doing my due diligence. I wasn't reading. I hadn't studied for this assignment that I came to ask him about. And like, he saw through it. Like, he had really good emotional intelligence and just read right through me. And like, he made me like sit there and he's like, I'm going to come back when you actually have a really good question. Because right now, like, basically you weren't prepared. But he taught me a lot of like hard lessons. So in finding a mentor, the advice that I would give now is being really clear on what you need and finding a team of mentors. When I lost Dr. Zhu in my sophomore year, what was hard is like, he was just so amazing. He was all of the things wrapped up in one mentor. And it was hard for me to let other mentors into my life. But over time, I realized that I needed different mentors. I was grateful that I had a mentor he was a chemist. And he saw me like I was deteriorating with work. It was hard to concentrate. It's hard to study. It was hard to do school after I lost my mentor. But over the years, I've had many mentors. And so the advice that I would want to give for those who are seeking, just be clear about what you need. Not every mentor is going to have everything that you need. And there's difference in mentor, someone really guiding you, and an advisor. Sometimes you may just have an advisor who gives you advice on what classes you need to take, what major, what internships you want to go to. But be clear on what you're needing in a mentor and seeking it from those places.
Very
Any other
cool.
questions?
Nice. So another question would be, obviously, you broke down this topic so easily, but for people that might find, physics complex, or, the idea of, these wavelengths that help us see these images, what would you say are maybe some tips that you found to help you better understand and grasp this topic?
Yeah, that's a good question. It kind of goes back into that teaching. Actually, the more you know the nitty gritty details of something, the more complicated concepts of something, often it helps you to explain it to the public. And let me just give you an example. That sounded complicated, even as I'm saying it. I'm just going to frame it around my studies of James Webb Space Telescope. I knew nothing about James Webb Space Telescope when I came to the Space Telescope Science Institute. But one of the things that I do, and I would encourage others that are wanting to get in this field, is doing a lot of research. And doing a lot of research. And so there's James Webb, jwst.nasa.gov. I stayed on that website. Any new press release that was launched out, all the nitty gritty details. Sometimes when I'm talking to the general public, they don't want to know like all the different instruments and what they're doing and the wavelengths they're doing. But over time, I really learned what they are. And so I would say like really diving down into the specific topic that you want to talk about, and remembering the questions you had. I think that helped me. Like I had questions like, well, what's wavelength, and like what was so special about James Webb being able to see in infrared? And I posed my research on their website, and I posed when I was listening to different speakers, kind of with those veins in mind. And so go in it curious. Go in it. You don't have to know it all. Again, like I said, I was an optical astronomer when I was studying for my master's degree, and I became an expert about talking about James Webb. So just wanting that hunger and desire to just do the due diligence to find the topic, and then you'll become really good at being able to articulate that over time to the public. But this is advice that I've given to people when you're talking about something very specific, that when I do public speaking conversations, I'm always taking a mental note, and sometimes I even write it down. When people have asked me so many different questions about James Webb, and I've kept a tally over them. Some of them have been very specific about the wavelength or whatever it may be about James Webb, and I'm never afraid to say I don't know, but I take a mental note, I write it down, and then I go find that answer. So that's how you kind of build that expertise. But if you're just interested in astronomy, I would just say start looking, start going to the places. Like for me, I was wanting to learn more about James Webb, and so I found the reliable resources that I knew I could go to. So that's part of that answer. So that was a long way to answer that question.
Yeah, no, that was good. Someone asked, what is an optical astronomer?
Yes, so optical goes back to like what Hubble season. So not all are space-based. Actually, the work that I did was in Cerro Tololo in Chile, but it's basically being able to see in the visible wavelengths of light that you're seeing here. So that's the optical astronomer. It's just the specific wavelength that we study. So the work that I did was with Orion, actually studying the spectroscopy within Orion. And sorry, another complicated word. Spectroscopy. I can never say that word the first time I try to say it. Basically, it's breaking down the individual components of light. So I wish I had with me a diffraction glass, but have you ever seen white light go through a prism and you see the rainbow? That's basically what happens with a spectrometer, is that like light comes through and then it breaks it up into its individual components. I just want to show this. It's not perfect example, but these colors actually indicate to us as astronomers, though it's visually amazing, the colors actually indicate to us the molecules and the elements of what this nebula is made of.
That's incredible.
Yeah, thank you. Any other questions?
question, Jessica. You had talked about in your description there's a difference. Can you hear me? Yeah.
Yes.
Okay. There's a difference between the telescopes on the ground and what's in space. So, like, what is the difference and what do each of those telescopes capture?
Yes. So I didn't go in detail on this, but yes, that's a great question. I'm gonna go back to full screen on this to show you. So in this image here, it's one of my favorite images to talk about this. Even when I was going to look for this image, I was like saying in my own dialogue, like, this is my favorite image. Okay, so why this is my favorite image is because it shows you, and I'm sorry I didn't describe it, that this is the amount of wavelength that gets through Earth's atmosphere. And so here we are with Earth's atmosphere. So some wavelengths get down, the ultraviolet, the visible, some infrared get down through our Earth's atmosphere, but you still have to be really high altitudes. You'll see that the radio wavelengths get straight down. Very little is lost with the radio wavelengths of light. But the reason why we have to have space-based telescopes is because not all wavelengths reach through our atmosphere. There's other challenges too. In radio, what's great about radio astronomers, so I am not, is that very little, unless it's like storming and thundering, they're able to observe. So right now, as an optical astronomer, to your point earlier about what's the difference in optical astronomy, like we need a good night and clear sky. So if it's cloudy, like if I were doing observations in Chile when I was doing it for my thesis work, if it was cloudy, we wouldn't be able to observe. We need dark, really, really dark skies, and we can't have rain. Some of those barriers are taken down with the radio. And so we have the space-based telescopes to be able to get these wavelengths, the gamma ray, your X-ray, visible. Hubble does visible, ultraviolet, and infrared. Then you have Spitzer, who specifically sees in infrared wavelengths of light. I meant to include it, but I didn't get to it this time. Actually, I'm sharing with, well, I can pull it up. Actually, I could pull it up really quickly. One of my favorite images is Eagle Nebula. I meant to include this in my slides, and I'm sorry. It's a great example of this. Thank you guys for bearing with me in real time. Okay, this is one of my favorite images. Oh, I love this image. Okay, so I'm gonna blow it up. So this is the Eagle Nebula. It's also a place where stars are born. The image that you see is visible on the left, and you're seeing it in the infrared. And I love doing this image when you kind of have, yes, first show you the visible, then I show you the infrared because it has a real wow factor. The visible, this is what we can see with visible. This is what Hubble's able to see in the visible. And you, as you can see in the infrared, you don't see all these stars. And so more than just like aesthetically to our eyes, that infrared light allows us to see through that gas and dust of these nebulas and really be able to study like these stars that are forming here. Like, had we never seen this in infrared, we wouldn't know that these stars are being born. And what I was mentioning earlier about James Webb is that in objects like this, if there are solar systems that are forming, they're forming in these gas dust that we cannot see through in optical wavelengths of light, but we can with infrared wavelengths of light. So that's the power of optical and visible. Same with radio. Radio and infrared on these longer wavelengths of light really allow us to study that gas, dusty regions within our universe to understand these fundamental questions of how did our galaxy form? How did our solar system form? You can really only study those in great detail in the infrared and the radio. I hope that answers your question.
Yeah, seeing it side by side, like, wow.
Yeah.
Yeah. So we have about one or two more questions, and then
Sure.
let you share your last words. So, you know, this presentation has been so amazing, and you know, the stories that you showed. You mentioned being in Chile, doing this research. So for those who want to follow your path, you know, teens that are maybe looking at applying for college, what should they be focusing on?
That's a great question. If you're wanting to go into this field, there's so many different pathways. I'm always intrigued by this question, and I'm grateful to share my journey and experience. It's just amazing that I have the platforms that I have. I just have to pause for a second and say I'm amazed at the platforms that I have and the way that our STEM field has changed, that all of these different majors, all of these different degrees are so important now. And I'm just grateful so part of my answer just has to go into that, being very flexible in kind of what you're doing. But if you're wanting to go to study, what has really helped me be a great science communicator is that I understand the fundamentals of the science. And so if you're wanting to go into astronomy, the basis of astronomy comes from physics. And so you'll need to take your physics classes. You're going to need to take your math classes. I was very fortunate. If you're wanting to follow my path, if you're a teen now, if you're middle school now, if you're elementary now, like, please don't be afraid of math. You're going to need it. What helped me, it sounds like it was so seamless. I went to Grambling, I declared my major of secondary education with a concentration in math, and then I suddenly went into physics. What made that successful, even though it was really a challenge, is that I took really advanced classes in high school. So I was taking my AP physics, I was taking AP calculus, I had taken all 3 algebras, I think, at the time that they were. But having a really, really strong math background allowed me to transition relatively easy into physics. And so I would say, first, get that fundamental knowledge. Don't be afraid. I tell this story often to students that, like, I did not like math, like fractions, or something about fractions and math that just freaked me out. But I had amazing teachers who walked me through it. And I'm glad that thing that I was so afraid of in high school, that I actually got really good at. And like, had I not had that strong math background, it would have been really hard for me to be in this. So I would say, one, if you're younger, if you're a teen, if you're even in elementary school or middle school, like, don't run away from your science. Don't run away from the math and the science parts of that you can be really flexible. Advice that I got when I went to Duke University that my professor was able to set up, when I was asking for advice. I really believe in seeking advice and asking elders for input. The thing that people kept telling me is, if I actually wanted to teach physics and I actually wanted to teach math, then get a degree in that. And so that's what allowed me to more easily change over into physics. And so I would say, if you're wanting to get into this, if you're wanting to get into education and public outreach, if you're wanting to get into science communication, one of the pathways is to get a degree in physics. What I was saying earlier about all the different pathways, and I'm so glad we get to talk about it, is that there's also other ways. There are English writers. There are artists. I don't have an example here, but in radio astronomy, sometimes you can't put visually what you're seeing, and you need graphic artists to create these amazing dynamic videos and infographics. And so there's so many different ways to get into science communication. But if I would answer one pathway, if you want to get into physics and astronomy and you want to study it, I would say declare your majors within the sciences. And again, I just want to preface that there's so many different ways if you wanted to get into science communication.
Wonderful. That actually answers both questions. Is there any last words that you would like to share? Please do.
Yeah, I want to say first, thank you, Takia, for this opportunity to speak. I'm really, really grateful for that. My last final thoughts, I would say, is like, follow your passion, follow your dreams. Don't be discouraged. There's a lot to be discouraged on, but be encouraged that we are out here. For Black and Brown students, like, I see you. So on my platforms is Auntie Jess, and that stems from my amazing mentor that I had, Dr. Zhu, and the aunties that I have in my life. But we're here, we support you. What's so great now about the times that have changed is that we have social media. We're able to find each other. We're able to support each other. That's actually how we got connected to be here today. And so Continue to follow your passion, continue to follow your dreams, continue to be unauthentically yourself. That's what I would like to leave with that. Thank you.
Thank you so much, Ms. Harris, for sharing your experience and those awesome images of James Webb. Thank you.
Yeah. I'm glad I got to be here today.
Well, hold on, let me. Okay, I'm sorry, I was trying to show back my face, but I just want to thank everyone for coming to this cafe. If you have friends that have missed it, it'll be on Facebook Live, it'll be on our YouTube channel. I wish I knew the YouTube channel, but we'll post it in the link. But thank you so much, Jessica, for doing this. Like, I learned so much. I'm a chemical engineer. I know nothing about the sky other than when I fly in it. So you've made it interesting enough, like not enough for me to like get up and get a telescope, but enough for me to like go to the website or at least like pay attention to some of the pictures. And
Yeah.
I've learned so much. So thank you so much. And for those of you looking at all of our other programs, be sure to follow us on social media. We're on Instagram, Facebook, and Twitter. And I think Carlin put where you can tag us and Miss Harris if you do her activity.
Yes,
the link is
please.
in the comments, right? So when you make these beautiful images, please tag us. So thank you so much for joining us. Be sure to reach out to Jessica if you want to learn about astronomy, because Carol and I know nothing about it. That's why we put these amazing STEM professionals for you. And have a great evening. Thank you so much.